So if we have angles between 0 and 360, we're going to get some questions that have some specific language to it. So I'm going to explain what that language is and then how to answer the question. So we have to remember that every ratio has two angles that correspond to it. So what I mean by that is sine of some angle is root 3 over 2. And we remember, hopefully, our special triangles. And opposite over hypotenuse, because that's what sine is. Root 3 over 2. So the sine of 60 degrees which is in quadrant 1, is going to be equal to another angle. So let's draw 60. And that's going to be equal to another angle. And if we remember the cast rule, sine is positive in the first and second quadrant. And I have a positive ratio. So if I consider 60 degrees away from the x-axis, that would make this 120 degrees. So it's 60 degrees away from the x-axis, but that's not how we measure angles. We measure angles from 0 around. So that's 120 degrees. So 120 degrees in quadrant 2 has the same angle, the same ratio, sorry. So if you type in your calculator sine of 60, you get root 3 over 2. If you do sine of 120, root 3 over 2. So we're going to get some terminology here that we got to define a little bit. So the initial arm, principal angle, and terminal arm. Initial arm is always here at 0 because our angles are measured between two lines. So we have the initial arm and the terminal arm. So this is the angle that's created by these two lines, the terminal arm and the initial arm. The angle that's created is called the principal angle, the one that we're measuring. In any other quadrant other than the first one, the initial arm stays there at 0. And this is the angle we're measuring, so that's the angle that's created, which is the principal angle. But what we do is we use the related acute angle. So that's the distance from the x-axis to help us figure out the ratio of the principal angle. So they're all going to have that terminology of initial arm, principal angle, and terminal arm. Determine the primary trig ratios, not rations. I don't know why it says that. I'll blame autocorrect. Ratios for the principal angle created by a terminal arm that passes through the point 3, 4. So what that translates to is there is a line that goes through the point 3, 4. And that makes an angle. What is sine, cosine, tan of that? So if we make a right triangle out of that, based on the coordinates, this would be 4 because it's 4 up, and this would be 3 because it's 3 across. So if I'm thinking about sine, cosine, tan of that angle, I need to think about opposite, hypotenuse, and adjacent. And the problem is I don't know what the hypotenuse is. But we said in the previous lesson that this is called the r now, the radius. So we're going to figure out what that is. So we're going to go back to elementary school and do Pythagorean theorem. 3 squared plus 4 squared is equal to r squared. 9 plus 16, so r squared, 25 r squared, so r is 5. So now that you know that, we know sine, cos, and tan of theta. I don't know what the angle is. We could figure that out using our calculator, but that's not what the question's asking. It's asking us for the primary trig ratio, so sine, cos, and tan. So sine is going to be opposite over hypotenuse, 4 over 5. Cos, adjacent over hypotenuse, 3 over 5. And tan is 4 over 3. So that's in the first quadrant. Let's see what happens in the second quadrant. So determine the primary trig ratios, not rations, for the principal angle created by a terminal arm that passes through the point -6, 8. Oops. Change colors too early. So this is our point here at -6, 8. So again, we get a right angle triangle where the vertical distance is 8 and the horizontal distance is -4. So we got to figure out what r is now. So we used Pythagorean theorem before, but really it's x squared plus y squared equals r squared, which is Pythagorean theorem basically, but using x and y and r instead of a, b, and c. And this is also the equation of a circle. So if I plug in my coordinates, I'm going to figure what r is. It's going to be 36 plus 64 r squared. 100 equals r squared, or r is 10. Okay, and your ratio, your radius is always going to be a positive number because it's the distance from 0 to the point. So it'll always be positive. It's only x or y that can be negative. So sine of theta would be 8 over 10, or reduced to 4 over 5. The cos of theta would be -6 over 10, or -3 over 5. And tan theta, -8 over 6, or -4 over 3. And theta isn't the angle where the red triangle is. Theta is from 0. What we're using is the related acute angle, which is called beta, I think. The related acute angle is telling us, looks like a B, what the ratio is. It's just based on the quadrant, it's going to change the sign. So we remember from the cast rule that sine is positive in both the first and second quadrant. But cos and tan would be negative. And this is why. The opposite, or the adjacent side, is negative. So cos and tan both have adjacent in it. The other ones are positive. So that makes cos and tan negative because the adjacent side is negative. And you can see up here that we have the same ratios. So if we found out what theta is, we would see that this angle theta and this beta would be the same. And you can also see that the ratios here are the same as the ratios here, but just different signs for cos and tan. So if we think about point P having the coordinates x, y, so this is y, and that's x, we can come up with a general form for what sine theta, cos theta, and tan theta are from 0 to 360. And remember that this would be r. So sine theta would be y over r. Cos theta would be x over r. And tan theta would be y over x. So if I know a coordinate, point P, I can figure out r, and then knowing what x, y, and r are, I can then fill in the sine, the cos, and the tan of that theta, just by knowing what the point is. Didn't have to draw it, don't have to make a picture or anything. I can just use Pythagorean theorem or the equation of a circle and then figure out what the ratios are. But what happens if you can't make a triangle? So asking for the sine, cos, and tan of 90 degrees. So the problem is that 90 degrees is there. I can't make a right angle triangle to figure out what the opposite side is adjacent and hypotenuse is. So here's what we're going to do. I'm going to give this a coordinate, and it doesn't matter what it is, as long as it's on the y-axis. So just to make it simple, I'll make it 0, 1. Now, r is the distance from the origin to the point. So if the distance or the point is at 0, 1, that means the distance is 1. So now I know what x is, y is, and what r is. So if sine of whatever angle is y over r, and in this case, we're talking about the sine of 90, y is 1, and r is 1. So the sine of 90 is 1. Now let's think about what cos would be. So the cos of theta, if we go back up here, we figured out it's x over r. X over r. X is 0. R is 1. So 0 divided by 1 is 0. So the cos of 90 degrees is 0. And we figured out that in general, tan is y over x. Right? Y over x. So if I take those values, I know y is 1. And x is 0. I have a problem here. Because we can't do 1 divided by 0. It's undefined. So you could do the same thing for 0 degrees or 360, 180, or 270. Just plug in a point, 0, 1, or if it was here, I'd do 1, 0. So over here, I do negative 1, 0. Over here, I do 0, negative 1. And then you know what x, y, and r are, and you plug it in, then you can figure out what the sine, cos, and tan of 180 are, or 0, or 270. So even though you can't make that triangle, like we do in all the other ones, you can still figure it out. All right, see you next time.